maybe. So really nice to see everybody back here. I was here in 2004, I think it was, when that was my first notebook, so it's kind of strange now I'm actually presenting from here on the whole thing. So what I'll actually introduce is one of the aspects I'm actually heavily involved with, which is the SLS 2.0 Controls and Science IT sub-project update. SLS 2.0, I wasn't part of the naming convention, or the naming committee, I should say, but 2.0, you know, usually with a 0.0 release, you wait for the 0.1 release, but hopefully people will come along either way when it gets going. I should really say at the start, I don't do any of the real work anymore. This is all done by my colleagues, quite a few are in the audience, so please make sure you ask the colleagues from Controls, Science IT and the Beamlines for the real details of everything that's going on. I am just now the manager, and I don't get to do the fun stuff anymore, but at the same time, it's really great to actually follow what's going on and actually the activities people are doing. So PSI is a very strange site where we have, as Thierry mentioned at the start, we have all the additional facilities of Swissfell, the neutron, the muons, and the Swiss light sources. So when you're trying to do one upgrade of one facility, that creates some interesting challenges, because apparently all the other facilities still need to be operational and actually run at the same time. And you saw the aggressive upgrade program we had in the introduction talk. So our resources are split across the board, and that's a fantastic opportunity to cause a lot of headache for a lot of people as they're trying to do that kind of work and actually run the facilities that are going. But it does mean that we have a huge amount of expertise and a lot of experience across all the facilities, and which we can actually share. So there's some great opportunities as well. For those who actually want to play synchrotron top trumps, these are roughly the numbers where we've got the current SLS, where we're going to reinvent the wheel and actually come up with SLS 2. The main upgrade is going to be for the storage ring and some of the beamlines. So to give, I didn't actually put the numbers on here. So the upgrade cost is around 130 million for the main phase of the ring, the storage ring, and these 5 beamlines and some of the IT aspects that go along with that. This mixing of keeping the old LINAC and the booster is going to cause a lot of interesting challenges for our controls colleagues. So those are the kind of things that they're now having to look into and deal with, actually, this kind of a hybrid old new systems, and actually the challenges that poses as well. But that's the background we have, that's the funding we managed to achieve. There is this follow-on upgrade program for the beamlines, who actually will then actually go for other sources of funding to actually do their own upgrades accordingly over the time period that we will actually, I'll touch on in a second. Of course, new beamlines, new opportunities, and it's also a good breakpoint to actually review what's worked well with SLS, where other places are. So we're actually looking across the board as to what we can actually learn from other places, what we can build on, what we can improve on. The timeline is roughly now, we're here roughly now. The dark time is currently scheduled to start in October next year, so just over a year away. And that's likely to, that's been challenged quite a bit because of obviously the global situation on availability of magnets, IT, and all the rest of it. But I have a feeling we'll definitely be going ahead with that dark time. But the decision point for that will actually be, well, in a couple of weeks' time, whether or not that's still going to be feasible based on where the tenders are and the delivery schedules are. For the beamline delivery themselves, we have a phase 0, as I think Kate mentioned as well. One of the PX beamlines is part of the phase 0, where we're trying to get some of the beamlines upgraded before the dark time. And then onwards from that, we have 2 phases. Phase 1, which will obviously include the phase 0 beamlines, where we actually get those coming online sort of mid to late 25. And eventually, even after a second shutdown in 2026, we'll go ahead and actually get the rest of the beamlines operational. These are probably more our priorities. Maybe some of the beamlines will try to do things themselves, but we certainly have to prioritize in this order as we agree and put the resources on there accordingly. Project structure, really boring, but it's questions that's come up about budgets. What we've been very fortunate with is from the very start is that the controls in the science IT is at the highest level of the project management. So that means when someone says, oh, we can delay something, or we can move a beamline later, that means I can say, well, there's resource implications for that, there's IT resource implications for that. We can challenge those. You can tell the amount, who's got the budget by the amount of smiling that's going on. So, so most of the budget is in logistics and the storage ring. Phil's always happy, to be honest, so that's probably not that reflective. But certainly we are by far the smallest budget, but with our manpower and the IT, it's roughly in the region of about 5% of the overall budget. There are other funds that we do have available as well. There's the traditional, we have an operational budget, which we're sort of collecting and putting in towards it as well. But this does mean that we have a very high profile as an IT group in the overall program itself, and everything is considered accordingly. A key driver for this setting up this sub-project was to actually clearly define the hierarchy. So PSI has specialized groups which are sort of grouped together, which makes the most senior, the common line management for us all being the director itself. So that if we had conflicts or issues between either IT or the beamlines or something like that, we don't want to escalate it that way all the time. So the sub-project is a clear way to define a hierarchy, as well as the SLS 2 project across the board. And we do have a clear path to the most senior management when there are operational difficulties, prioritizations, and issues across the board. Another goal was actually more positive, which is actually try and exploit the new technologies, try to harness, looked at the challenges, revisit approaches, all those kind of things, which are relatively standard, I think, but it's now a clearer idea to actually have that coordinated, as opposed to expecting and hoping individuals do that in an uncoordinated way. We're not perfect, but we are getting there on this now. To give you an idea of the scope, so within the sub-project itself, you can see that we have everything from the firmware right through to the cybersecurity guys. And that's, we're trying to now, in the process of actually defining tasks and activities, and the groups themselves are actually working very hard to define what their workload, their manpower load, and where activities will be as well. Key to the success is the help I get from both Elke Zimmer, Stefan, and Marie Yao, and they are the key people who actually help make sure everything runs smoothly on a day-to-day basis. So we did a conceptual design report, not just part of a bigger conceptual design report for the overall project, but one specifically for the controls and science IT aspects. We had that externally reviewed, had some great feedback, have acted on quite a few of these things, of course, because we always listen to review boards. The conceptual design report was a bit strange because some aspects of the technologies we're using are very mature, other aspects are very, very conceptual at this time as well. It's available online. You're welcome to take a read and help our statistics. That QR code probably doesn't work, never mind. But the details in the CDR covered everything. So I actually left this up there not because I want to tell you the details, but to actually give you a bit more an idea of some of the infrastructure and the choices that we've got. So we are an ethics-based facility. There's a lot of work on the standardization across that, on the interfaces, and then all the way down to the beamlines as well. Initially, we thought that there was just going to be an element of evolution on the machine, on the accelerator and the beamline side from the controls and the electronic side, but now it's turning slowly into more of a revolution where things are actually changing quite dramatically, trying to keep up with it and get the benefits of the newest technologies. On the beamline side, there is definitely more of a revolution, and I'll come to that a bit more details there. The IT resources obviously have a huge impact and by that I also mean the software on what the beamlines can do, how quickly they can develop, share or adopt techniques, and also how well operations and the experiments overall will actually run and actually achieve what they're trying to do. PSI and SLS have been immensely successful in history, but we're trying to build on that now as the challenges are getting bigger, as we've heard in a lot of presentations already. So to give an idea of the responsibilities across the facility, we have one group in one division, which is predominantly the business IT, which includes the networking, we have the controls and the electronics guys on the EPIC side of it are heavily involved up to one layer. And then we have the beamline staff very responsible on everything above the EPICs layer today on the current facility. And then downstream from that, we have the new department, Science IT, which are more responsible, historically been more responsible for the storage and the IT and the longevity of the data, as well as some of the analysis tools as well. This is has to be a collaboration between all these groups. But for this, and because of the NoBugs audience, I'll focus more on that side of what's left going forward. So I'll use the list here as, if you like, as the template for the rest of the presentation. So the beamline experiment control. So at the moment on SLS, this was left predominantly to the beamlines to actually determine where and how they were actually going to put a layer above the epics for the users and the user communities that they actually have. We've ended up with a range of tools. Some are actually really well developed and fantastic and good support. Others are implementations of older software, and some are things that still have to run because no one actually knows how to deal with things. But there is a huge range there, and what we were asked to do by the laboratory heads was to review whether or not this is the best way going forward, or whether or not there was a existing tool and a community out there that we could actually look to apply at this layer for SLS 2 instead of this buffet of systems currently. So we had a focus session. It was run by Marie and with great contributions from controls and the beamlines, where we actually looked as much as we can. And thank you very much for people in the audience who contributed to this. It really helped our education and an understanding of what was available. We then, after the evaluation, went into a review and actually trying some of the tools out to where we are now, where we've actually made a decision that Blue Sky currently looks like a really strong candidate for that area, a strong community and a background. The beamline staff like it. What we need to do now is actually try it out in earnest and not just on a test system. So we're currently in this first phase where we're going to actually try next month, actually running our first test and experiments. Then do some real data collections, and then hopefully let an instrument or a beamline go live on its own. Ideally, that would be the point where we have enough information to actually make a decision point as to whether or not we can really commit to this kind of a new service layer at the facility. We may be asked to look at that, to look at it sooner, but ideally that will be that point. It is unfortunately quite far away though. So one of the things we're obviously looking at is Blue Sky, as was presented in the Blue Sky session, is a toolbox, not an application. So we have to decide as a facility which of these tools that are useful for us, which aspects are we going to put together, which tools don't quite fit, based on the nature of our facilities and our dependencies and infrastructure, and actually try and come up with a working operating system. That's what we're currently doing. There were some posters and some sessions on that to actually go through what tools to use, feasibility, and also looking at the long term, not just the short term, what we need on that. A big part of this will be the assignment of responsibilities between the controls groups, between the science IT and also the beamline staff, because there is currently no new resource for this kind of service in this new layer of the facility. The eventual decision will be made by senior staff based on the information that we have. And obviously, the big thing for us, well, certainly for a lot at the moment, the bigger thing is operational long-term support and actually how we're going to actually be able to run it. I think technically we can already see that the tool is fine. It's really just now whether or not we can support that sensibly at the facility. Good. Data and data treatment. At PSI, we did, as part of the CDR, we did a requirements gathering, and it was really clear that although things were working well, they were certainly not going to scale at the moment as it was. So there was a clear requirement to actually look at improving the software and utilizing existing software anyway. Dedicated personnel to look after these services and how they were run, not just the beamline staff, and also thinking about linking more and more simulation and modeling work, AI work to the actual experiments to actually get more out of the experiment and the data being collected as well. On the data reduction and compression side, we were trying to address these. There are a lot of activities already. I think there was better presentations that I'll give on this already been, but very familiar that we're looking at reducing the crystallographic data, imaging data, using existing tools to the best of their abilities. And there are some very nice initiatives, either as part of LEAPS or with the Swiss Supercomputing Center for us, and the Swiss Data Science Center, to actually look at ways that we can improve the data, the quality of the data, and actually reduce the database. Obviously, drawbacks were already mentioned in previous presentations, but what has previously been the case here is that there was no centrally coordinated activity. We are going to start addressing that as part of the SLS 2 activity so that we can actually get the information across the instruments in a more structured way. Data reduction, reconstruction analysis. Kate gave a presentation earlier, as I mentioned, so she gave an introduction to some of the MX tools. These tools have been predominantly developed as research tools by the beamlines on our infrastructure, but now that we're looking and discussing the best ways to actually scale these up and support these long term, whether or not it's in crystallography, tachography, or imaging as well. These are some of the beamlines that are going to have significantly more data, so we need to make sure that we're actually getting the most of the information out of that data, using the expertise and the tools that we already have, and actually scaling those onto local compute resources or further afield. And such as on-queue, storage and computing. Currently, this is the scale of the IT that we actually have. I'll start you talking even quicker. Oh, right, okay. Scale of the computing we already have is probably less interesting than the scale of the computing we actually foresee will need, which is significantly higher, probably an order of magnitude. And there's quite a bit of variability on that as well. The beamlines tell us what they are in a live document, what they expect to be collecting, what the detectors they're actually achieving to get. But we know the beamlines are ambitious and they actually change and that will migrate going forward. So the big problem is, as part of the upgrade, we actually have to move everything out of the computer room that we're in, because the computer room won't be able to operate during the actual build. So this is kind of our predictions, and we're in the planning process, and we'll go out to tender quite soon on actually how we actually upgrade the IT to meet the requirements that they actually need. We are also in touch with the Swiss Supercomputing Center, which is on the other side of the Alps, where we actually hope to be able to utilize their latest Grace Hopper-based HPC, and the same as Nick has mentioned, same issues. HPC centers want the biggest computing, not actually what actually our users necessarily need. On the information management, I can quickly go through this because these have already been done. There was a poster by Scilog, so experimental logging will be done using the system there, and the SciCat, which has already been well introduced as well as our data catalog for long-term data catalog. And on that, I will just thank everybody who actually contributes significantly to the work. Thank you.
Yeah, you can speed up. You may need to do that for the upgrade as well. Right? Any questions for Alun?
Otherwise, you can reach out.
Mark has one. Okay.
I have one question. I'm missing one word in all of that.
Nexus.
Streaming.
Oh, thank God. Yes, well, at the moment, there are initiatives localized to the beamlines on the data streaming. And we are seeing what has already been done, and we will actually come up with a framework to try and put in place for that based on what's best for the experiment, and actually obviously how we treat the data stream as well, and what we can do on top of it. Learning a lot from what's happened obviously in Swissfeld, as well as what's currently ongoing at Beamlines.
Okay, then we thank Alun once more.